So I have been learning quite a lot about large language model toolings, and this winter break I decided to write an app just to accelerate the things I'm learning, and I'm just going to do a very quick demo of the app right here. The app is a research assistant, AI research assistant that is kind of generic, but I actually built it from the point of view of a scientist in terms of the day-to-day operations of a scientist in general. So it has a data science component to it. It has a reviewer component to it. Once you have your manuscript written, it has a research assistant component to it, and it has a paper agent component to it. And I'm going to go through each of these and actually go through the demo. I'm going to be using my OpenAI key, so if you're using this version, you would be using your OpenAI key. And also, this was built over the winter break with very limited time to spare. So if you are using this early version, you are going to come across a few bugs. I've tested, but I'm sure you're going to come across a few bugs. Okay, so now let's get it started. And I'm going to start with data science agent. So the first thing I want to do is to grab my OpenAI key. Okay, so let's see. Okay, now that I have my OpenAI key, the next thing I am going to do is I am going to put in a data set that we are going to use, and this data set, very briefly, is a data set from a work that I recently published, actually as a preprint. It's the lipid, it's the identification of lipids that discriminate ovarian cancer from other kinds of gynecological cancer. So mainly you have the class, which is the ovarian cancer and the non-ovarian cancer, and then you have the lipids that actually discriminates them, that we have identified in the study that discriminates them. So I'm just going to have a little chat with that data set and let's see where that takes us. Okay, so let's start. Well, how can I help you? So I would say I want to compare the relative abundance of a lyso phosphatidylcholine, so a species of that, which I believe is the first one, colon, and I'm going to say compare the relative abundance of that lipid in ovarian cancer patients and non-ovarian cancer patients and non-ovarian cancer patients. Okay, so let's see. So what's going on here is a process that is called react. So it's thinking and it's actually acting, and this is basically what's going on. It's synergizing reasoning and acting in large language model. So it's able to reason and it's actually able to act. So what do we have? Okay, so basically, as you can see, that there are a lot of thinking and action going on. Here is some of the Python code it's using in the background. So that's the class, what are the unique class, non-ovarian cancer, ovarian cancer, and then it goes to pick up the tools that will be used to do that. So it's using the group by method to identify the mean of the different classes and actually compare them. So it's basically now telling me the relative abundance of that lipid is higher in non-ovarian cancer patients with this average compared to the ovarian cancer patients. Okay, so that's kind of like pretty neat. So you can get very quick look at your raw data set. So maybe we should just turn this up notch a bit and say build a machine learning model that discriminates between ovarian cancer and non-ovarian cancer patients. So now we're turning to do something a little bit more complicated, and let's see how we actually get it. Again, what's going on here is that method that I actually quite refer to. So let's start taking a look. So already it's running some code. Let's see what's going on here. So it's still thinking, it's still acting, and we can see some action with sklearn going on here. So it's it's already writing some machine learning code, label encoder, and so on. So this might actually take some time. So I'm going to pause it for a little bit and then we'll get back to it. Okay, so it says a machine learning model using random forest classifier was built to discriminate between ovarian cancer and non-ovarian cancer patients, achieving an accuracy of 77.6% on the test data. So, I mean, the nice thing is that, again, large language models do hallucinate. I mean, they're getting better by the day, but they do hallucinate. So, you want to actually confirm what's going on. And then in this case, you have the code and you can actually go through the code and see if it's making sense. And one of the things that we do as scientists is that we publish our research work, our research findings. And so you submit to a journal, and then it goes through a process of the peer review. And this process can be lengthy. I mean, it can be lengthy. And I came across this paper a while back, and this was what actually led me to build this. Essentially, basically, I use some of the methodologies, and it's a large-scale empirical analysis of asking the question that can large language models actually give useful feedback on research papers. And then they essentially came to the conclusion from their study that overall more than half of the users found GPT-4 generated feedback helpful or very helpful, and about 82% found it more beneficial than feedback from at least some human reviewers. Okay, at least some human reviewers. And again, they made the point here that we still need human experts as the foundation of a rigorous process, but perhaps some of these can actually give you feedback when you're writing a manuscript at an early stage and things like that. So we're going to try this out, and I'm going to get one of the early drafts of the paper I wrote in grad school here. And basically the paper is essentially okay, so this is the paper. So the paper essentially machine learning enabled renal cell carcinoma status prediction using multi-platform urine-based metabolomics. So basically we're taking urine samples, we're doing NMR, we're doing mass spec on that, and we want to use the metabolite profile to basically detect kidney cancer. Okay, so I am just going to then review this, and I'm going to type review. So submit query. And this would also take about a minute. Okay, now it's done. Actually, it ended up taking much less than a minute, but basically you can see the paper, like significance and novelty, goes through the potential reasons for acceptance. Okay, why should they be rejected? It was talking about sample size, clarity and robustness of statistical methods, and in fact it was even suggesting methods of actually improving the manuscripts. Okay, so discuss potential confounders and limitation more thoroughly and how they may affect the results, and I think I ended up doing that in the final manuscript that actually ended up being published. But again, it talked about more diverse patient population that might actually enhance the generalization of this finding. The study was actually mostly Caucasian, if I can actually recall well. So anyways, the idea is this would give you feedback much faster, and I even have an hypothesis that this could even be much better if we can find a way to sort of incorporate relevant literature as contexts to this AI model to actually do a very good job of giving you a very detailed review. So that's kind of like this review section. Okay, so we are going to go to the next section of the app. Okay, so the next section of the app is this research assistant. And again, as scientists and researchers in general, you research stuff. And the way we do research these days is we do it on the web. We go to web pages and see if we can read papers that support or refute some of the things we're thinking about. So this would actually draft a report for you. It's going to be about 1,000 words tailored to your query. And I had some issues implementing these, and there are methods that could make it much better. But again, I did this in a very limited time. So we're going to try out some of these and see what we get. So I guess we've been using biology examples mostly. Let's sort of use a query on computer science. So let me say this. So what are the recent developments, okay, in using transformers, okay, for computer vision, okay, and I'm saying that use archive for sources. Okay, so I'm going to tell it to use archive for the sources. So what are the recent developments in using transformers for computer vision? So I'm going to submit the query. And this, if it works well, should do a very detailed report. So it's going to take about 2 minutes to actually complete. Okay, so look what we have here. Actually, it took a little bit less than 2 minutes, just a little over a minute. And then basically what this actually does is it goes through the archive websites and crawl and look for papers in that field. And basically vision transformers, I guess that's VITs. And it basically did a rapid report. So it's introduction, hybrid vision transformers in visual segmentation, image classification challenges, 3D segmentation, semantic segmentation, revising transformers through convolution. So basically detailed reports, and then you can get this inside in-text citations, and then at the end, you can basically click on these, and you take you directly to those papers that has been reviewed, that has been included in the references. Okay, so this is the last section of the app. This is the last feature that I built on the app, and it's chat with papers. So I am going to use one of my latest preprints for this. It's serum lipidome profiling amongst Korean women with ovarian cancer. I'm going to just ask some questions about it. I haven't built memory. Well, I'm having some problems with implementing that in LangChain yet. So I'm going to just get this and drag that so that we can begin chatting with this document. And it's also best to ask specific questions for best results. And I can start by asking, nope, don't save. Okay, let's get that out of the way. Okay. So what are the machine learning methods used in this work? Let's go. So we can ask that question. Let's see. Yeah, you got it. So random forest, logistic regression, k-linear snowball, support vector machines, and I believe a voting classifier. And then we can even ask, since this is a clinical metabolomic study, you can say, tell me more about the patient cohorts. What do we want to know about the patient cohorts? Then it goes into the paper and basically retrieve the sections of the paper that are relevant and tells us. So the patient cohort contains 208 ovarian cancer patients, 117 non-ovarian cancer patients, and so on and so forth. So basically this is kind of like really nice tools that will make I believe scientists much more efficient in the age of large language models. So okay, so that's the app in general. So if you have any feedback for me, you can just leave a comment or send me a message. Thank you for watching.